So, I mean, some people might wonder, well, how come you haven't kept a working machine, John? Why?
How can he keep it if people take him from him?
Right.
Well, trouble is, when people see, gosh, we've got millions of dollars here.
Yeah.
We've got to take it and own it.
Mm-hmm.
And they either steal everything, your equipment, to stop you working, so you can't do nothing.
Mm-hmm.
They then think you'll get on your hands and beg them, you give them the secrets needed to make that magnetic setup right. Of course, I don't submit.
So it's,
to
The last unit was back in '82.
right.
And
The last one that was
right.
over Unity.
He had it between the walls. He was powering his home. Eventually, the Midlands Electric, was it Midlands Electric Company?
Midlands Electric.
Yeah, they noticed he didn't have a bill, and yet he had electrical power, and
Right.
that's when he had a lot of problems.
Right.
Go to the one point I'd like to push here is that people will say, well, if you made it in 1946, why can't you do it now?
Mm.
Well, in 1946, the Mega SG was £108 to me. I'd like to see somebody go and make an SG today for that money. It costs millions to make one up.
Right.
The next thing is that those types were made just for our own pleasure. It took 3 months to make each one. Production, that's useless. You can't do that. So I had to rethink how we could turn that into a production model. This is what Morris is working on. The suggestions have been put to him, and he's working on it. And so far, it's green. Gone green. It's okay. I'm satisfied. Everything's looking good for a production machine that can be mass-produced. If all goes well, and there's no problem, the first unit, we can up and down the power on it, and it makes no malfunction. I can say, right, we can go on to the production line now with it. Now, with this thing is, it's a new technology. We have now changed from the old system to another system which is fast and quick to mass produce. At SG, you need at least produce a couple of thousand a week on the line, or it's no good from the point of economics. So it's a matter of producing a system that you just can bang them out. And at the moment, that looks very good. At the moment, I'm quite happy how things are going. But the cost today to do it is terrifically. And every year the price is going up. And we can't control the price. It's the market that's controlling the price. So the sooner we get this going, the cheaper the units will be. And the more lines we get running, the cheaper still, because when you buy more and more bulk, the price goes down.
Okay.
So these are issues people don't think about.
Some people wonder why you haven't applied for a patent for this device.
But
Can you
the
explain?
big thing is that we're trying to get something we can mass produce, that produce the energy as the original machines did. And secondly is, while we're struggling to get this, you've been stopped time and time again by people who want to own it. They should just steal your property, so you can't move. You got to start again.
I know if we try to patent the U.S., they always screen these patents.
Oh, no, I'm aware of that.
It rings bells, says this
Yeah.
could be a weapon and all that, and then they can immediately stop you.
Right, yeah.
So we rather copyright it or just keep it in-house. In fact, the magnetization process, we're not going to patent it. It'll just be a company secret.
Right. And Fernando, have you looked at any other over Unity devices, like for example the Stan Meyer cell or Pons and Fleischmann? Because I'm actually looking at those now and studying them, and I believe there's credence.
I really don't know much about those other ones. I'm focused on John's technology.
And is there anywhere where people can get updates on your progress?
Certainly. We have a website called SearlSolution.com.
SearlSolution.com. Okay.
SEARL solution.com.
And if you do get over Unity, what would the next stage be then?
Well, we have to be careful. We have to make sure it is fully developed to the extent that we can present it.
Right.
One of the most dangerous positions we can be in is just having one demonstration unit.
Right.
We'd rather have a lot of them, just to make sure that there are no incidents.
And let's say you've got your demonstration unit that demonstrates over Unity. you then need to prove it in a university somewhere.
I wouldn't call it over unity.
Well,
It's
it's
a unit that's converting energy,
Right, right.
and which is why you have this temperature drop.
right. So the actual source of the energy for the electric current comes from the
Is-
surrounding temperature of
It's
the room.
ambient, right? So your room temperature will drop. That's the only consequence of it.
Right. So would this not, let's say you were using it to power something quite big, you know, like, I don't know, a big machine, would it not completely freeze, you know, would the temperature drop not be just vast? So it would cause problems with, do you know what I mean? Or does it not work like that? I mean,
You just work it outdoors, but
right.
it is scalable. The smallest unit we can make is 15 kilowatts using John's way of designing.
Mm-hmm.
And that's the beauty of the SCG. Is simply the more massive, the more power you get out of it.
Right.
And
So if you're powering your house off it, let's say, I don't know, let's say 5 kilowatts, something like that, there'll be no problem with it. You create, you know, making your house really cold or something.
well, we should ask him. He had one for 31 years operating his home.
No.
So did you convert it to 240 volts, John?
Yeah, the power was for 240 with 50 cycles raised
Yeah.
to give us 50 cycles.
So
Bear in mind that when you're not drawing power, it has an idle speed.
right,
It keeps running, never
Yeah.
stops.
they're like a turbine generator in a power station.
Just idle. It means it's fully charged. As soon as you switch on, the flow starts and the rollers speed up.
As you add load onto it. That's just phenomenal. So it's got its own built-in governor then, that's
right.
what you're saying.
It immediately reacts because think about what you're doing. You're drawing more current out of it. Consequently, it drives the rollers to move faster.
Yes. You must bear in mind, it's a linear motor on a magnetic bearing, but also a diode is one direction. Secondly, it's an auto transformer, and again, the input in this machine is coming from all the fabric around itself. It is putting it in uniform motion. It is now pushed out on the outer copper or aluminium, whatever material you pick, goes onto the back of the roller.
Right.
Now, the back of the roller, due to rotation, is short and it's longer on the front. Newton's law is clearly seen. The electrons coming back of the roller gets to the top very quick. It's accelerating. Now, it can't turn to go around it because to do that, as Newton said, you've got to apply a force. So they just come off to the next ring, which is waiting to receive any energy around itself. And the process keeps on till you get to the final rollers of the third set. This then jump to the coils or a brush, depending what system you're using. Then conventional concepts come into play. In other words, you've got very high voltage, so you drop it to the voltage that you want. This gives you, well, current's proportional to the voltage, so you get your current.
So now that's a very good qualitative description, John. But have you tried to get someone to quantitatively do this using equations? I mean, every electric device you can model mathematically. I mean, is this something that you've considered, Fernando?
I know the SCG is based on mathematics.
Yes.
You cannot design it without it.
Yeah.
But and John has, I think you had a whole book of numbers and based on the squares, right?
Yeah.
Okay.
I have demonstrated, because printers and mathematical books for schools said there was only one type of square you could do. It's a 3 square. And I told them, you're wrong. You could go to infinity. And the mathematical system for each grade, I call them 1, 2, and 3. That's all the grades, mathematical grades we have. 1 is all even numbers. Another place, all odd numbers. Fit this one mathematics, regardless. The other half of all the numbers are again divided in half. The first slot I call type 2. This is a mathematics, which sort of 4 squares are identical more or less. They're switching and switching both directions. This switching going on all the time, which tells me that energy can switch to matter, matter can switch to energy in a flick of a finger. Whichever goes out of step, it will correct it.
In Einstein's famous equation, E equals mc squared.
Yeah.
So.
And in these mathematics, when you set them out, it's interesting to see this game tells me all about your structure. It tells me all about the planet structure. It tells me everything. If you look at it, you'll find the same rules as shown in the hopscotch.
I have to say, I can't get my head around where the hopscotch and the grid and the random numbers where they add up to the same number. I can't see where that fits into the model. Maybe it's because I've been trained in electrical engineering and I'm too,
Right, this is a new technology. It puts you into a new window, a new world of opportunities.
Right.
And it's going to be highly beneficial for all of us because we're talking about here energy and transportation.
Yes.
So it should make our civilization viable, which I think right now it is not. We're kind of degrading the environment as it is.
All right, and John, all right, and Fernando, I really hope you get a working prototype. But
we made a lot of progress, and we're definitely headed in that direction.
Right. Well, it's very exciting to meet both of you.
The thing is, people must remember, because I had no formal education, because I'm deaf, I haven't got hearing bones to hear with, I have developed a system. This half of the skull is dead to all vibration.
Yeah.
They don't receive or identify any form. This side, I identify two bands, and I have to fill in the missing bits when one talks. One has to be very close to the bones, oscillate enough for me to, make something of it. But what happens is the teachers never took any notice. They worried about why you couldn't learn. And again, so I wasn't programmed as they program you as a child. So they sort of put you in a box, but they couldn't put me in a box. All I was doing, looking at everything that was happening and questioning why.
Yes.
And eventually became the real, so to say, point that really made things happen was when I started my apprenticeship as electrical engineer. And then the first docket I took to the stores for cable, bang, what does that mean? 2 and a little 2. So I said to the foreman, what does that mean? That's 2 squares. Well, I thought, what's 2 squares? He just drew on the paper, 4 squares, 2 by 2. I said, well, what's the value of this? Oh, nothing.
Right.
So I said, well, to me, a structure, that's a structure, must have function. No matter what the structure is, there's a function. I have to find out what that value to those squares are.
Right. Yes.
And that's this work that showed me 1 and 2 squares were not squares at all.
Right.
They are DNA.
You're right.
Of
So you're
the
trying
square.
to differentiate between what's purely mathematical and what is reality.
What John has found is his mathematical matrix, which is called the magic square as well, is able to simulate nature's processes. And what John has done, because what he saw is that we're living in a random state.
Right.
Okay. And what he has transposed it so that the output is uniform. Then you got coherent currents and so forth.
Right. Okay.
The SCG is based on on those figures. That's how we design it.
Okay.
That was just a matter of time and devotion to find out what the hopscotch was saying.
Right.
I mean, and bit by bit, my work brought the images together, and I could see this square business fitting in. And it was clear that the work was dealing with elements, it was dealing with energy of immense energy output and pressure, and then also the second one that is clearly was to do with flight using the same technology, only on a much more complicated system. Bit by bit came together. The first generator I made was generator, and it decided for some stupid reason to go to the ceiling. And in the end, when it went through the ceiling, the second one, I decided, well, give it a body. We'll get the generator, give it a body, and we'll see what we can do with it. And, of course, I got shot at because I frightened the pigeons. Well, that's what I told the police. He frightened my pigeons. What he meant was the pigeons put such an output, and they didn't like the job to have to keep cleaning this up. every time one of these things went up.
Yeah. So it went through the actual roof of your house, right? Right. All right then, John. Well, thank you very much for talking to me.
It was nice to meet you.
I've loved listening to you, both of you, and good luck with your research, and we hope you get a working prototype. Thanks, Fernando.
Thanks for having us.
Yeah, thank you, John.
Thank you.
All the best.
Of course, there's a lot of exciting things in my experiment where that would amazing what's happened.